All right, so um, I welcome you once again. This is a special tutorial session, and particularly um, to address issues on the graph, even as raised by some people also in the course evaluation. So primarily based on that, I want to do this particular thing again, and then to clarify issues. But what I would do now is that I want to first of all let you know that the graph is an important graph. And of course, you should know that this graph underpins engineering. And wherever you go, whether building technology, civil, mechanical, whatever kind of engineering you do, this graph will not skip. Okay, so it's important to understand this graph. All right. Now this, I told you I'm going to use this question. I told you I'm going to use this question to address the problem. And so I'll try and take a snapshot of this particular page. Okay, so we are going to use this particular. Now this was a lab test performed, and typical readings that were taken. And based on that one, you have to plot the graph to determine a lot of engineering properties from the graph. Now, before I start plotting, first of all, this question, we have been given certain parameters. We have been given the initial diameter of the bar. We have been given gauge length, which is the original length. We have been given diameter at fracture. So at this point, I expect that everybody knows the parts of the graph. This one is a load extension curve. A load extension reading. So you have the load and you have the extension. Every load has an extension as we move on. Now, when you want to plot the graph, you need a load and you need the extension. That is, if you want to plot load extension graph. If you want to plot stress strain graph, you need to calculate the stress and also calculate the strain based on the values given in the question. So you need to be very careful and know which graph you have been asked to plot, whether you are plotting load extension curve or you are plotting a stress strain graph. Now, if you note that you are plotting a stress strain graph, you have to use the loads and the extension, calculate the stresses and the strains, and redraw another table for that, and then use their values for the graph. All right, so I want to share once more time. I want to share some gist that I gave. I can't find my gist. Basic. Okay. New share. Why can't I find? Okay, let me stop sharing this one and see. Let me go to Newshare and see whether I'll find it. This is quite interesting. Oh, okay, the thing is here. Sorry. All right, I want to share this one. I gave some clue. I gave some clue in plotting the graph. And this is the clue. You need to choose a scale. And it's one of the most important things you should be able to first do. First of all, you need to calculate the difference in the X data. So if I say X data, the graph that has been given, you have the, per the graph we are going to plot, the load is plotted on the y-axis, and then the extension is plotted on the x-axis. So in this case, the X data is the x-axis, okay? The X direction is the extension. So look for the maximum and the minimum value, and then calculate the change in X, which is maximum minus minimum. When you finish, that answer, divide it by the number of large boxes or squares. Okay, let me open my notebook. Windows is whiteboard. Okay, so I think that let me go to the whiteboard, and then I think that will be fine. Let me share my whiteboard. Whiteboard. Okay, my whiteboard is still opening. But let it first open. Okay, but what I'm saying is, first of all, we are going to plot a graph. This is how our graph is going to look like. Our graph is, let me erase this mark. Our graph is like this, okay? This is the y-axis, and this is the x-axis. Okay. And our y is the load, and our x is the extension. So everybody here should know that per our graph, our y-axis represent the loads, and the x-axis represent the extension. So first of all, look for the minimum and the maximum value in the x-axis. So even before we even go there, may I know the graph that I gave, the assignment graph, the coursework graph. Let's look at the x data. tell me what is the minimum value for the X data and what is the maximum value? You can put your answer in the message box. Minimum value for the X data, maximum value for X data. What's the minimum for the X data? Maybe the minimum first. Minimum for the X data. Minimum value. Hanifa, it's not 0.5. No, it's not 20. Nanaya, you don't know what is minimum? You don't know what is minimum? If you have a values, you cannot determine what is minimum. Yes, it's 0. The minimum is 0. What is the maximum on the X data? Maximum for the X data. What's the maximum for the X data? Why are you mixing up things? I said the X represent our extension. Is that not so? So why are you mixing X with the load and all that? Okay. So maximum for the X is 5.85. That's correct. Now, in our case now, the Y data represent the load. So once again, let's look for what is the maximum Y data. Minimum, let's look at minimum first. Minimum the Y data. Let's look for the mean and max. So what is the mean for the Y data? Minimum for the Y data. That one too is 0. Okay. What is the maximum for the Y data? What is the maximum for the Y data? What's the maximum? Okay. All right. So that's the maximum. Well, that's fine. 261. Okay. Okay. All right. So that's fair. Okay. So now we've got that one, right? Okay. I've decided to make the video short. So I want to do all this background stuff before we start the actual plot so that it becomes very, very short video and easy for people to refer to. Okay. Now, so that is about that. Then once you have been able to detect that, the remaining one follows. Your graph sheet, your graph sheet is like this. Originally, your graph sheet is like this. The longer one is vertical and the horizontal is short. So what I want you to do is that count for me. In this case, this is how the graph sheet has been positioned. So just note that for now. In this vertical, I refer to this as vertical, I refer to this as horizontal. So I want to ask you, in the graph sheet, you have, unfortunately, I don't know. You hold on. Bright, what is your question?
Well,
Bright.
sir, I sent some graph sheet for you. That's what I wanted to tell you.
Oh, you sent it through which medium? On the WhatsApp?
Your direct. No, 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 no.
On the
Direct
Signal?
message in the chat. Yes, yes.
Okay, let me see whether I can find. Okay, great. Let me download it. Nkurɔfoɔ abin wɔ fie a wɔn abin rɔfo. Document. Why is the image quality like that? The image quality is somewhere. Okay, that's fine. So thank you very much, Obin. I want to know whether all of you can see this graph sheet here I've shown here. Can you all see it? If you can see my graph sheet now, you can just say yes. All right. Okay. I wanted a better graph, but the way. This graph, is it a standard graph? 1, 2, 3, 4, 5, 6, 7, 8. No. Graph now me project any papa. Let me use the one I've been sent and see. 1, 2, 3, 4, 5. Okay, I'll use what has been sent to me. So let me stop sharing this one. Let me share a new one. Go the one I projected earlier. Okay, can you see this one? I've shown another one. I've shown another one. Okay, all right, thank you. So this one, courtesy of being who has granted me this wonderful graph. Um, okay, let me use this one to teach it that way. At least having a loaf is better than none. Okay. So this is how the graph should be positioned in front of you for now. And this side, I refer to this as vertical. And I will refer to this as horizontal. For now, you forget about look at your graph. Ideally, there should be this from here to here in a proper way. Must be, if you count, it should be 10 boxes, okay? This one should have been 10 boxes, but that's okay. I want you to count the big boxes, the big line, the thick line. Okay, count the big boxes on the X direction. And tell me how many boxes did you count on the horizontal direction? Horizontal. How many boxes did you count? Okay, 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 okay. So I can see varying answers. Okay. Don't I even have a graph sheet here? Okay, I'll use some of the students' graph sheets. The work presented to me. Let me try to use one of them. So per a certain graph sheet I have here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Per a certain graph sheet I have on the horizontal, if I count, is 10. Okay? So if you count yours and it's 8, that's fine. But in our case now, the horizontal, we are going to use 10. Okay, now count on the vertical and tell me, so on this one is 10 boxes. Okay, this is big boxes. And then on the vertical, count and let's see, how many boxes do you find there? Okay. Hey, some people's graphs are totally different, but that's fine. It's not an issue. Okay. So per I'm using somebody's assignment graph. I'm using that graph sheet. So in that case, if I count on the vertical, I am getting 12 big boxes. Okay? All right. Okay. I also want you, so per this class, we are going to use Emmanuel Edging. Normal graph, vertical is not 10 and horizontal is also not 10. That is not a normal graph. A normal graph is a rectangular graph, not a square graph. Okay? Emmanuel Edging, a normal graph that you buy on the market, we have used in JSS and all that. It's not square, it's rectangle. So it's not 10-10. I disagree with your post. I'll give you a thumbs down. I disagree with your post. Okay. Now you have a graph in front of you. Per this class, let us know that we are going to use in the X, or let me say we'll take it horizontal. We'll take it as 10 boxes. And then vertical, we'll take it as 12 boxes. So that's fine. Now, the next thing I want to hear from you, take one box, one big box, and count and tell me how many number of small boxes is in that big box. Count it and let me know. How many boxes is in the, how many small boxes is in this big box? Okay, fair enough. So once you have seen that, that one too is 10. So let us also note here that big box contain 10 small boxes. Okay, good. All right, so now, so like I'm saying, basically, this graph is not giving the true picture because this one, there should be a small division somewhere here. Okay. This one should have been like this. There's a small division, so it's like this graph. So ideally, from here, let me change the. From here to here should have been the ideal one big box, so that the middle line here usually is very faint. You get it? So you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So every 5 box you should note is actually a 1 centimeter. Okay. So that big box as I we're referring to, which contains 10 small boxes, is actually 2 centimeters. Okay. Okay. Bright had shown me another graph again. Obin, there was being papa. Hey, Obin, what being? All right. Now, I'm taking you now to the my space. Let us now start work. New share. Let me now share my where is it? Okay. I'll now share my notes. If you can see my notebook, you can just say yes. My notebook with a snapshot. Okay, good.